Hi there, and welcome to today's class. For today's class, we'll be trying to solve the 2017-2018 and 2022-2023 physics practical exam. All right, we'll be focusing on the graph section, which is always question 20. So this question here says, this question was repeated in 2 years, 2017-2018, 2017-2018, and 2022-2023 session. Now the question says, the following readings were obtained in an experiment. You have this table here. They said make a table of t squared where t is equal to t over 10. All right. II says plot a graph of t squared against h. III says determine the intercept on the t squared and the slope of the graph. Then IV says write down the linear relation between t squared and h. All right, so let's get this done. So first things first, if you check the 2022-2023 section, they said make a table of t squared against h. You were not told that t is equal to t over 10. Instead, they said the time for 10 oscillations is given as this. So when they say the time for 10 oscillations, it means that t is equal to what there? T over 10. So in this case, they gave you the relationship straight. Why in this year, 2022-2023, they just told you that you had 10 oscillations. They expect that you should know that to get the period t, divide this t here by the number of oscillation, which is 10. All right, so first things first, they said make a table of t squared. So before we get t squared, we have to get the value of t. There's no space for t. So first of all, we have to get t. And what's t? We said t is equal to what? The capital T is equal to small t over 10. That means for me to get my t, I would have to divide the value of small t by 10. And it means this. So it means that we said capital T is equal to small t all over 10. And that's equal to, let's take them one after the other. The first one I have there is 36.0. So it becomes, the first one becomes 36.0. Divide this by 10. Please, this should be done on your rough section, right? That will give you 3.6. Of course, in seconds. For now, we're not considering the SI unit. So I have 3.60 as my answer, or 3.6. Let's look at the next one there. Next in there is 35.6. So I'll divide 35.6 by 10. 35.6 divide this by 10. That gives you equal to 3.56. Okay, the next one there. The next thing there is 35.1. So it becomes 35.10 divide by 10, and that gives you 3.51. Okay, next if I have 34.3, so it becomes 34.3, divide this by 10, and you have 3.43. Next if I have 33.1, so divide 33.1, so I have 33.1 divided by 10, and that gives you 3.31. And then finally I have 31.6 divided by 10, so I have 31.6 divided by 10, and that gives you 3.16. So I have this. So I've gotten the value of t for each of them. We're asked to find t squared, right? This value t squared. That means I'll have to square each of this. So to get t squared, I'll have to square this one here. So these are the values of t. Let's get the value of t squared. So I'll square this one here. 3.60 all squared gives you 12.96. But then coming back to my table, observe that my units were all given in one decimal places majorly, right? Except this few, which is 60, which is something as 6. So majorly my SI units here were all given in one decimal places. So I'll provide my answer in just one decimal place. So this will be equal to 13.0 in one decimal place. All right. So 6 gives you a plus 1. So 9 plus 1 gives you 10. That gives you 13. 13.0. I would square 3.56 and that gives you 12.67 as your answer. 12.67 in one decimal place gives you 12.7 as your answer. Okay. Next up I have 3.15. So 3.15 square. If I square 3.51 please, 3.51 squared, that gives me 12.32. 12.32 in one decimal place is 12.3. Also, I have 3.43. I'll square this. 3.43 squared gives you 11.76. Approximate this to one decimal place, you have 11.8. Right? So proceeding with this, next up I have 3.31 squared. 3.31 squared gives you 10.96. Approximate this to one decimal place gives you 11.0. Okay. Now, lastly, we now have 3.16. Lastly, we have 3.16. I will square this. If I square 3.16, I'll have 09.99, which if I approximate to one decimal place, I should have 10.0. All right. So these are the results. So I'll just take these values for t squared. These are the values for t squared. These are the t squared values. Right down here, you have them. I'll just take these values and I'll impute them in my table. So you go back to your table and input your values. So for t squared, the first one I have there was 13.0. So 13.0. Next up was 12.7. So I had 12.7. Next up was 12.3. So I had 12.3. Next up was 11.8. So I had 11.8. Next up was 11. So I had 11.0. And finally, last one there was 10. So I had 10.0. All right, I've expressed the value of t squared all in one decimal place. So I has been answered. Make a table of t squared. I'm done with that. Next one says plot a graph of t squared against h. So I'm plotting a graph of t squared against h. So t squared would be on the vertical axis. That's this one here. While h would be on the horizontal axis. All right, so let's go and plot this graph. All right, so we have a graph, which is this. And in our graph, of course, we have to find the value of the slope as well as the title of the graph. So for this case, let me get the title of the graph. All right, so for this, we'll have that the title of the graph is simply, I was asked to plot a graph of t squared versus h. So it becomes graph of t squared. T squared is in second squared against h, which is in cm. All right, so this is what the graph should be. So this should be a small h, okay, in cm. So this is what my graph title should be. So what's the next thing here? My next task is to get a scale. Don't forget, every graph must have a title and a scale. So I've gotten my title here. Let's now get the scale of the graph. So next up, scale used. Scale used. So my scale used now will be let from this point here to this point is 1 unit. So let 1 unit represent what I have here is 1. So I'll say 1. The unit on the t square axis is second squared. So 1 second squared on the t squared axis, and let what I have here is from here to here is 1 unit. So I'll say let 1 unit represent So on 1 unit here, I'm seeing 5. So this calibration is in 5. So I'll say 5. The units here, as you can see, is centimeters. So 5 centimeters on the H axis. Alright. So this is how we get the title and the scale. Alright, so you've gotten your title and your scale, and you've drawn your graph sheet. So this is what my graph sheet should look like. Going back to my question, so we've answered question 2. Plot a graph of t squared against h. We've gotten that. Question 3 says determine the intercept on the t squared axis and the slope of the graph. So I'm looking for intercept on t squared axis. Luckily, the software gives me the intercept here, and it's giving my intercept here, this value, this one here. And from here, we can see that the intercept, which is this point here, that this point where this line crosses the y-axis, which is the t-squared axis, it's saying that the value is about 13.35. Since this axis is in second squared, that becomes second squared, perhaps. Yeah, so I'm having 13.35. That's the intercept on the t-squared axis. All right, so intercept. So let me go back to this. So question 3. So I would say intercept on the t-squared axis is 13.35 seconds squared. So this is the A part. The B part, we have to find the slope. Of course, slope will be equal to change in the parameter on the vertical axis, which is t squared, all over change in the parameter in the horizontal axis, which is h. And that's equal to t2 squared minus t1 squared all over h2 minus h1. Alright, so we'll go down and pick up the value of t2, t1, h2, and h1. Let's go get these values. So first things first, let me take off these ones here. Okay, let me take these ones off. Alright, so I have this. Again, when it comes to picking slope, we've said this countless times. When it comes to picking slope, you look for that point where if I have my vertical line such as this, and then horizontal line such as this, look for that point where this line moves this way, and of course cuts this axis like this. Right, this point, this exact point here is where you look for to take your dots. Right, but for this one here, the software already gives me the answer of the slope as minus 0.038. That's about minus 0.04. Right, so I don't really have to do it solving, but then just for teaching purpose, the easiest way to get your slope is to take this point you used. So you can trace this value here. This point here is 18.0, 12.7. This point here is 18.0, 12.7. This point here is about 84.0, 10.0. Alright, just for teaching purpose, I'd want to zoom in so that we can see this clearly. Let me zoom in so we can see this clearly. Okay. Alright, so I think this should do. Alright, so we have this one here. So what's next? So the alternative would be I would look this point here, 18.0, 12.7, trace this one here to the y-axis or the t-squared axis, trace this point here downwards. Also, we took 84.0, 10.7, so trace this one downwards and trace this one to the left. So I have this case. All right. So So then I'll have to take this point here, this and then this. So take this as your slope. That means slope here. This value you have here is the value of t2 squared. The value you have here is the value of t1 squared. The value you have here is the value of h2. The value you have here is the value of h1. So I have this one here. So it means that this point here. It means that this point here is h2. This is t2 squared. This point here is h1. This is t1 squared. All right, so let's take in these values. Let's take back these values and then we'll use them for our slope calculation. All right, so going back to my solving, so that's equal to, that means t2 squared becomes 12.7 minus t1 squared becomes 10 divided by h2 squared, or h2 becomes 18 h2 becomes 18 minus h1 becomes 84 or 84.0. All right, let's get this solved. What do you have here? So first things first, let's work with numerator. We have 12.7 minus 10, and that's equal to 2.7 all over denominator. I have 18 minus 84, and that's about minus 66. If I do this, I'm having 2.7 divided by minus 66, and that's approximately minus 0.04, the same value we had from the calculator. So this proves that we are further correct. Our next task now be, what is the SI unit of my slope? Now my slope is simply changing t squared all over h. T squared is in second squared all over h is in centimeters. So that becomes second squared per centimeters. So this becomes the slope of my graph. Alright, so I've gotten my slope of the graph as minus 0.04 second squared per cm. I've also gotten the intercept on the t squared axis as 13.35 second squared. Alright, so with this, we can say we've answered question 3. Question 4 says, write down the linear relation, between t squared and h. Now, what do we know about linear relationship or linear relation? We know that for the equation of a straight line graph, that y is equal to mx plus c. So this means y is simply the parameter on the vertical axis, which in this question is t squared. M is simply your slope, which in this case we got the slope as equal to this value here, which is minus 0.04. Okay, next up, your x is simply equal to the parameter on the x-axis, which is h. And then finally, you now have c. C is the intercept on the t squared axis. That's the vertical axis, which we've gotten the intercept here as 13.35 as my intercept. So c is equal to 13.35. Alright, so expressing this, it means that the linear relationship becomes y, which in this case here, let me write this way. So therefore, the linear relation between t squared and h is, so y, which is this one first, t squared is equal to m, which is this one here, minus 0.04 m into x, which in this case is h. So h plus c, which in this case is 13.35. If I expand this, I would have that t squared is equal to minus 0.04 times h gives me minus 0.04 h plus 13.35. So hence this becomes the linear relationship between t squared and h. Alright, going back to my question. So that means finally we've solved question 4. Alright, so this is how you solve this particular past question. Okay, please, if you enjoyed this video, make sure you like the video. Also leave a comment. Alright, leave a comment, tell us you enjoyed the video. If it's your first time or if you've not subscribed yet, please make sure you subscribe to this channel. It encourages us as well as our growth. And finally, don't forget to share this video to your friends so that they can also learn. Alright, so this is how you can support this channel. Simply like the video, leave a comment, subscribe to this channel, and of course share this content to your friends so that they can also learn. Thank you very much and see you in the next class.